3.1 is about derivatives and rates of change. The slope of a tangent line is a limit as h approaches 0 of f of a plus h minus f of a over h. We're going to use this formula for slope to find the equation of the tangent line. So here we are with f of x equals 3x squared minus 1. So what we're going to do is we're going to use the definition above, and we're going to use a equals 2 because we're at the point 211, and 2 is the location of that point. So set up the limit as h approaches 0. Now, the first thing we need to do is set up f of a plus h. So that means I'm taking the expression a plus h and substituting it into x in 3x squared minus 1. So I'll write it out first. So f of 2 plus h, and then we'll find f of a. So write the limit as h approaches 0 of 3 times 2 plus h quantity squared minus 1. So that entire expression is f of 2 plus h. Now we're going to subtract f of a. So f of a is when I substitute 2 in for x, so that would be 3 times 2 squared minus 1. And that is all over h. Let's expand 2 plus h quantity squared. That gives me 3 times 4 plus 4h plus h squared. I still have minus 1, and I still have to subtract this quantity. 3 times 2 squared is 3 times 4. So that's 12 minus 1 is 11. Now I'm going to distribute the 3. So I'll get 12 plus 12h plus 3h squared minus 12. So you may have noticed I have a positive 12 and a negative 12. So those are going to add up to 0. And now all I have in the numerator are terms with an h in them. So I can cancel the h on the bottom with the h's on the top. So I'll be left with 12 plus 3h. And I can evaluate the limit now. What I'm going to do is substitute 0 in for h. So I get 12 plus 3 times 0, which is 12. So that means the slope of the tangent line is 12. So I'm going to write the equation of the line. I'm going to write it in point slope form. So y minus y1 equals m times x minus x1 is point slope form. So my y1 is the y coordinate we were handed at the beginning. X sub 1 is 2, and then our slope is 12. So y minus 11 equals 12 times x minus 2. You can leave your answer in that form. If you choose to make it y equals form, or if you needed it to be in y equals form, you would get y equals 12x minus 13. And now I have set up an example for students to do. So I will want you to pause the video and take time to find the equation of the tangent line using the definition of derivative. So pause the video now. Now that you're done working out this problem, show you the solution. A equals negative 1 in this math problem. I'm going to set up the limit as h approaches 0 of f of negative 1 plus h minus f of negative 1 all over h. To begin with, I want to substitute negative 1 plus h into x in the function. So that's going to look like 3 minus the quantity negative 1 plus h squared. Then I have subtraction, and then I have to evaluate f of negative 1. So f of negative 1 would be 3 minus negative 1 squared, and that's all over h. Okay, we're going to expand the binomial. 3 minus the quantity 1 minus 2h plus h squared, and then we're going to evaluate in the parentheses. So negative 1 squared is 1, and this is 3 minus 1, which is 2. Now I'll distribute the negative in front of the trinomial. 3 minus 1 plus 2h minus h squared minus 2. You may notice we have a 3 minus 1 and a minus 2, so that will add up to 0. And now in the numerator, I have terms that all contain an h. So I'm going to divide through by h, and I will get 2 minus h. So the limit as h goes to 0 is 2 minus 0, or 2. So 2 is the slope of the line, and I'm going to use point slope form to write my answer. So that would be y minus 2 equals 2 times x minus negative 1. So you could write that as x plus 1. You can leave your answer like this, or if you like to write it in y equals form, you would get y equals 2x plus 4. Let's consider particle motion. Suppose an object moves along a line so that its position relative to the origin is given by a function, s equals f of t. So S stands for position. This will be our origin, and you can think of this as the positive x-axis. The function f is the position function. It's often represented with the letter s. At time t equals a, let's put the particle at this position, and then some time passes. So the amount of time that passes, we'll call that h. So now the time the particle's at this location would be a plus h for h units of time later. So that means from the origin to this location, the distance is f of a, and from the origin to its new location, the distance is f of a plus h. Since f represents the position, we can look at the average velocity of this particle. The average velocity is the change in position over the change in time. So I'm going to represent change in position with f of a plus h minus f of a. And the change in time would be a plus h minus a. And that simplifies into f of a plus h minus f of a all over h. So that gives us an average velocity. We're also going to ask about instantaneous velocity. So that means we're going to consider the average velocity over a much shorter time interval. So we want h to get smaller and smaller and smaller. So we're going to take a limit in order to find instantaneous velocity. So take the limit as h approaches 0 of our average velocity. F of a plus h minus f of a over h. We're talking about instantaneous velocity ultimately, and we're going to represent this as the derivative of f. So the derivative of f is the rate and change of position with respect to time, and it's considered the velocity of the particle. The speed of the particle is the absolute value of velocity. So you can denote it in this manner. Note that velocity is a vector, meaning it has magnitude and direction, as opposed to speed. Speed is just a number or a scalar, which means it only has magnitude. We're going to look at derivative of a function. So we can just call it that now. It's the limit as h approaches 0 of f of a plus h minus f of a all over h. To practice remembering what this derivative formula means, I have some examples, and this is the setup for the derivative of a function. We tell you that this limit represents the derivative of a function, and we want you to identify what the function is and what is the value of a. What you can tell from our formula is The actual function shows itself at the start of this setup. Can you see the square root symbol there? Here is your a and here is your h from your formula f of a plus h. Right there I can tell that a equals 4. It looks like the function is the square root function. So I'm simply going to consider that as my answer, and what I can do now is check and see if I'm right. Am I right that this is the function? Am I right that that is a? And you can look right here to answer that question. Remember, what comes after this minus sign is f of a, right here. So all you have to do is take your idea of what a is, which is 4 for me, and put it in to our function. So I'm going to find f of 4. And f of 4 is 2. That is exactly what is there. So I have the function for part A, and I have the a value for part A. I do the same thing for part B. The function is showing itself right here at the start. This pi over 2 is your a, and this is h from the formula up here. So it looks like a is pi over 2. It looks like our function is the sine function. And now before I box that up, I'm going to check and see if I'm right. Is f of pi over 2, which is sine of pi over 2, equal to 1? Yes, it is. There's the 1 right there. So our function is sine x, and a is pi over 2. Okay, pause the video for a moment and decide the answer to part C. Pause the video now. I will give the solution to part C. The function is showing right here. F of x equals e to the x. And it looks like a is the natural log of 5. So I'm going to evaluate f of the natural log of 5, which is e to the natural log of 5. And that's our natural log, and the answer is 5. So that is true. Our function is e to the x, and a is the natural log of 5.